optimize for performance. You see, normally when we are dealing with data structures, we need to look for the shortest way so that we can be able to process the data within a short time. Okay, code optimization is normally very, very key for us, especially when you're, for instance, you're building maybe a shop, you're building an e-commerce site, and this e-commerce has to fetch products from the database and then show it to the user, and that needs you to use data structures which are very fast, and for you to use a method like list comprehension so that you can be able to fork that data very, very fast. Okay, so it's concise, it's better than the for loops, and it's like the loops, I mean, so it's faster execution compared to traditional for loops, and also it enhances code readability. And the syntax is a bit can a little bit interfere with your thinking. However, it's not difficult. Let's just work on it in code so that we see it in action. All right, so let me open another. See how many I've opened here. Still I can just use the same. Let me use the same, but let me move somewhere down so they can see. Oh, let me use an account. I think that would be better. Something different. Okay, got it. All right, so if you can see my screen, please let me know now.
Visible.
Okay, visible. Good enough. All right, so let me make it a little bit big. And okay. So we normally have an expression. This whole thing is called an expression because it's going to an expression is just a statement that will lead to a certain outcome. Okay, basically that's what it is. Yeah, it will lead to a certain outcome. And how do we write a list expression? We need an iterable. We need a loop. We need a loop variable. And I'll show you shortly what that means. A loop variable, and we need what else? We need a source of data. So because we need to iterate through a certain object, Python object, and also we need what I think we just basically just that. Okay, if I remember, I'll keep on explaining. So, for instance, you have these numbers. You have the simplest one. Maybe we want to square numbers, so we can say we want to square squares. So when we want to square these numbers, like maybe so we can just basically we want to square certain numbers in a certain range. We've used the range function for quite a number of times, so now you know how it's used. So we first of all, this is the loop variable, just like in a normal for loop, like you say for I in range and so forth in range something. So in this case, we don't use the for loop, but we say num, which is the loop variable. And again, this is now the syntax for num in maybe range 10. So we want to square these numbers in this range to 10, maybe from 1 to 10, or whichever the case it is. So we want to square these numbers. Instead of writing a long for loop, we just write a very short list comprehension code, and it's going to do that work perfectly for us, just like the way just like the way the loops work. So if we print this, this is going to it's going to, as you can see, it's given us, it should give us the squares. It's not given us the squares of that numbers, but I will also explain to you just a bit. So I want to square the numbers from 1 to I think to 9, because the last one normally is not included. So I want to square those numbers. So instead of writing that long for loop, I use this one. And so what's going to happen? As you can see here, we have squared because we are looping through 1 to 9. If we add 1 here, from the numbers in the range of 1 to 9. So if we add 1 here, then the numbers in the range to 1 to 10. And now if we print this, we get this one. Yeah, we get this one. So you see, so from 1 to 10, so we have 2, which has been squared, 3 has been squared, 4, 5, 6, 7, 8, 9, 10. All right. So that's how it works. And also we can remember we need an iterable object, which is this. This is an object, this is a list object, which is an iterable object that we need to iterate through. And we need a loop variable, which is this one. And we need an operation. Yes, I was forgetting. The operation is this. Yes, because this is what we want to do. The operation is basically what's our intention. And our intention here is to square each number in the range of 1 to 10, all right? Another thing that we can do with list comprehension, so for instance, we have these, we could be having like words in an object. So we can have words as iterable object. And these words could be maybe, subjects, programming subjects, like for instance, Java. For instance, Java, Python, and maybe Solidity. These are all programming languages. And maybe we have JS, which stands for JavaScript. Maybe we have Scala, and maybe we have R. There's so many. We have R, and so forth and so forth. And so I probably want to say a shorter word. So shortest or shorter word. Shorter words, and I want just to filter through this list of objects. So what I want to do, I just want to check if the number is short, then we print it out, and we can filter out using still use list comprehension. So we just check word, and for word in words, if word is less than or equal to, for instance, 4. Is someone picking up? So we print that. Benjamin, please mute them, please. You can mute them. So that Benjamin, can you mute? Ode, please. Ode. Benjamin, mute Ode, please.
Okay.
Yeah, so shorter words. So what I just want to do, so okay, this, I hope you're seeing what I'm doing. I'm going to take the shortest time possible so that I don't eat into Bobby and Benjamin's time. So so this is just a normal list object, as you can see, with the sequences of characters, as you can see. And then we have this variable which is holding for us this list. It's going to hold for us the result of this operation. And if we print now shorter words, the variable shorter words, so let's see the output. not supported between instances of string and int. So let me check where have we put if for word in words, if word len word, sorry, this should be len word. If the length of word, because you cannot we cannot iterate this particular object. So yeah, we use this length function to get for us the length of each of these, because we want the shortest, the ones which have lesser characters. They're like the characters are 5 or less. So that probably would be 1, 2, 3, or maybe Java, JS, and R. Yes, let's see if that's going to be printed for us. Yeah, and you can see Java, JS, and R have been printed out for us. It's sorted out for us. That another thing, maybe we can say word.upper and just word.upper. Yeah, so let's make sure that all the words are in uppercase, and it's gonna do that for us. But in this case, it's because it's just the ones which we have, it's filtered for us are in uppercase. Maybe if we don't use this upper, maybe we don't just say it this way, and we remove this other so we just print the words only. But now let's make them dot upper. So everything should be printed out for us. However, everything should be upper in this case. As you can see now, everything is upper. Yeah, I hope that makes sense. And what else did I want? Let me just check. I wanted, what did I want to do again? So now I wanted us to compare. I hope I don't have enough data, but it normally, what I want to do normally needs some chunk of data, but I want to show you how we can see which one is faster than the other one. Is list comprehension faster than loops or not? So let's take an example from here and check that. So for instance, we have this, let's import the time module, so that because you want to use with time, because we have to check the time, the list comprehension takes, and the time the looping takes, the for loop takes. So we import time, and then we want start time. So we want to start the process. So start time, we just want to use this function time.time to do the work for us, and then we need the stop time as well. So stop time is of course the same, time.time. So this is an inbuilt function that is given for us. So we just want to check what we want to process in here. What is the time, the difference of the time, and we will print out the difference of stop time minus start time. Okay, so now let's write something in here. So let's say squared. So we are squaring these numbers. Squared is equal to, remember again that for num, let me stop talking, for num in range, let's take a slightly bigger range. But the problem is, if you take a bigger one, it consumes your compute resources. And I'll add it. Once we get it right, I'll add it. So squared num, yeah, for num in range this. So we're looking for all those numbers in here. Maybe we can say this from 1 to that 1,000, and then we want to square them. I don't want to print it out, but we can print out just to check if this is working. But let's use a shorter one. So we can print just to check that our code is working the way we want it. Print squared. So let me clear first of all here and check if it's really worked the way I want. All right, so you can see the time is 00 because that's a very, very fast one. However, I will make it bigger. We don't need to, if we make it big, then we don't need to print it out. We just need to see the time taken. This is the time taken by list comprehensions. Now, and then again, we will check the time taken by a for loop, and then we compare which one is faster. Yeah, so this is the time taken by list comprehension. So yeah, okay, so that code is finished, and let's print it out. So we can see over here, the time taken by list comprehension is this one. So this is the time taken by list comprehension, which is 0.0. So don't worry about the yeah. So attention, it's about the typo, and probably let's put this one just to make it look a little bit visible. Okay. Now let's write the next code, the for loop now, so that we can compare these two. So now when we come to the for loop, we need to initialize an empty list. So you remember we use this constructor to create lists. So we use this constructor. This is for an empty list. So this is for num in a range. Let's use the same range. And in this case, we use, but we will add it because this is very negligible. We will not see anything meaningful. So let's see 1,000. 1,000, so yeah. So in range 1 to 1,000. So what I want to do, we can say that let the square, because we want to square, let the square be num this way, though we can make it even shorter, but let me just use this one for now. So this is the looping variable, this one, and of course we are holding the result of the looping variable in this variable called square. And then we want to use, you remember we did append, if you can remember, we use append to append something, like if you want to add something into a list, you use append, okay? And basically what I want to do, I want to populate this empty list with these numbers that are being generated. And these numbers are being generated, our data source is this one. The range function is generating for us the data that we need to iterate through or over. And what we want to do now is just to, I don't want to print it. However, I can print it just to show you. Let's just print this section only. Otherwise, it will slow down my machine, and I don't want to do that. So I can print the squares just to ensure that our code is running. And let's just print this particular section only. I think it's this one. Yeah, so we get this neatly, this kind of a triangle, you see. So those, and you remember we did this sometimes back. So the iterables are 1, 3, 4, 5, 6, 7, 8, 9. And are we squaring them? Really? Let me see. 1 to 11. So let me see. Yeah, I think. No, it's not squared for us anything. So for num in range 1, let me just use this one. And let me just use something more simple. And again here. And now let me just test 10 here. Is it squaring? It's not squaring. Okay, let's check it again. For num in range this square is equal num. Let me see. I think list range. Strange. No, it's not list range because this is producing list for us. I think that's the one. No. It's now it's printed the first one, which is not what we wanted. It's printing this one, but we need to print. And then the second one is this. However, this is not doing what I wanted to do. Okay, let me just remove this print here. Yeah, I don't want it to print. So, and I just want to ensure that this is running. This is what is it's not working the way we want it to work. We don't want lists, so it's just range 1000, 1, 2, 3. This will print everything again, but let me see here. I hope you can see my screen. So the first one was I imported time. It's gonna take my time, and I didn't want to do that, so I imported time. Yes, this one here. I import time. I hope you can see. Let me kill everything. That one out. This one out. Just remain with one. Yeah. Okay, so I've imported time again. So what were we doing? So squares, start time. Let me just call it start is equal to time dot time. Stop. The stop time is equal to time dot time. Then let me insert our code in here. So squared is equal to, oh, just a minute. Let me hook up the laptop. Okay, so squared is equal to, we use this, so num, we are squaring this one, so blah, 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 for num in range, let me just use 1,000,000, 1, 2, 3, 4, 5, 6, and I won't print it out, because if I print it, then again, it's gonna kill the everything. So I just need to print, we just need to print the difference. So we have this and this and this. We can just say squared this will not print, so square, because if we don't, like, I think if we don't print this out, it will not work otherwise. So let's print start, stop, minus, stop minus start. Yeah, and this is the time taken by list comprehension, so we can just say list comprehension time, list comprehension time is that one. And then this other one, let me initialize squares is equal to an empty list for num in same range, in range 1, 2, 3, 4, 5, 6. This is normal. Now the normal the normal for loop. And let me make it as short as possible. So squares dot append. So we are appending num. So instead of writing the other lines, I'm skipping one more line and I'm just multiplying, squaring those variables. Okay. And then we don't have to print it out. We just need to check all squares for num in range, blah, blah, blah. Squares dot that one. The next step is to, I'll take this again, start time here. Start time. And then I'll take this stop time here. It's because we want to measure the execution, how long this has taken as compared to the other one. Squares. We can print squares out of the for loop here this way. This just means, squares out of the for loop. The same way we printed it over there, and now we need to print time taken by the. This is the time taken. Loop time taken, looping time. So this can be looping time is, and that is it. So let's print it. Because we need to put 2 here. And here, of course, comprehension. So that's just typo. So list comprehension time is 0.4. Do you see the difference? And looping time is 0.6. So we see that list comprehension is shorter. Like it's faster as compared to. I hope that makes sense to us. Let's increase this number. So those were 6. 1, 2, 3, 4, 5, 6. So let's make it a trillion, I think. 1, 2, 3, 4, 5, 6. So let's print it and wait. So that's a longer one. So that takes slightly longer, but it should give us the output. So you can imagine if we, let's see, it's taking long because we have to, it has to process. Any question while I wait for that? While I wait for that, I think that's too long for the processor. So I might as well just interrupt the kernel. Let's make it 1, 2, 3, 4, 5, 6. Let's make it even shorter. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 10. 100,000. 100,000. So let's see if this will work. This works because it's a bit short, but still you can see the time that the list comprehension is taking is very short. 0.2, like those microseconds. And this is 0.06. Okay, so that's basically what I wanted us to explain, and at the same time we have used a few things that we have learned here. So my intention was for us to see how we can be able to use, we are using the lists here. In here we've generated a list by using the list comprehension method, which is more it's more concise and is for readability's sake.